right? So thank you all first for being here. I am Bogdan Vergelea. She's my colleague Oana Turbatu, and we're both working inside the Data Lake Foundation area within the Enterprise Data Management Tribe in ING. We're also part of a central team whose focus is on standardization and convergence of services that will be used throughout our organization, from wholesale to retail banking in Europe, but also around the globe, in North America, Asia, and Australia. For today, we would like to walk you through our ongoing journey to implement a data fabric, which in return will enable AI capabilities that can be used throughout multiple business units. We will share insights about how we started, where are we now, and what was our incentive to start all of this. Are you aware of Toyota's famous production system, just-in-time? At its essence, just-in-time is a pull system focused on making what is needed, when is needed, and in the right amount. In theory, this provides stable pricing for the customer and also keeps cost overhead in check. But in practice, it doesn't tolerate any error and can be extremely difficult to implement. And let me give you a real-life example here. A car company will no longer have to stockpile large amounts of parts in their warehouses, thus increasing their operational and storage costs. Instead, parts would arrive at the factory gates exactly at the moment as they are needed. In the same manner, our stakeholders want to access the data exactly at the moment that they have the need for it. Data fabrics will enable organizations to connect, query, search, analyze, and integrate their data, no matter where that data is found in the organization, without moving or copying it. And as the name just-in-time implies, companies can make data available exactly at the moment their business process is demanded. So as you can see, even a half-century-old concept, because this is how old just-in-time is, can still be in the spotlight today. So, why do organizations need the data fabric? Well, over the past few years, the term data fabric has become synonymous with enterprise data integration and data management. As you can see in the slide, some of the main components that can be found in large organizations. We have relational databases for the OLTP and transactional processes. We have data lakes. Your data lake should support the data of any file size and any format. Analytics and business intelligence capabilities. Your business users will source reports from these capabilities. Cloud data stores. If your organizational policies allows it, you can also push data inside public clouds, and of course, your application repositories. A lot of work needs to happen in order to interconnect any of these technologies, and this is where the data fabric can really shine. Data fabrics works in a similar way like the human brain. They use a network-based architecture to handle information by making connections rather than making copies. So in essence, a data fabric will deliver you integrated data from multiple sources through unified interfaces. And of course, in order to do this, a fabric needs to enable a very smart data virtualization strategy. And by leveraging on this strategy, users will be able to access their data no matter where it is in the organization, and access their data there. Also, proper governance is going to be in place to make sure that only the right people can access the right data sets. Let's talk now a bit about the global data fabric market. And let me start with a fact here. Global data creation is expected to surpass 180 zettabytes by 2025. And that's really a huge amount. Well, despite the vast amount of data that's being created, shared, and stored by large companies, their journey from data to decision-making still remains a big challenge. The global market size for data fabric platforms was $1.4 billion in 2021, and of course, it will continue to grow over the past few years. The banking, financial services, and insurance segment had the largest revenue share of more than 22% in the same year. On the second place, we can find the telecommunications and IT segment. And both these segments have in common the fact that they produce enormously large quantities of data. The banking and financial services segment, in which also ING does business in, like I mentioned, produces large amounts of data. And this data can range from credit histories to consumer spending habits. However, because this data is frequently kept in silos, extraction and aggregation can be a very challenging task for any team involved in doing this activity. Those segments would greatly benefit if they would adopt a data fabric approach or architecture to handle most of their data needs. Some driving factors for data fabrics in growth over the last few years were the digital transformation that we can all feel around us, and also the usage of online platforms. Many companies understood that their success and even their survival heavily depends on how they effectively work with their data. Now, let's go back to ING. Our journey started back in 2014 with a handful of engineers who were tasked to design and implement the first iteration of the data lake. Due to the limitations that we had back in the day, we simply had to use a replicated model, right? But that meant that each business unit at the time would have to host and manage its own infrastructure, deploy its own iteration of the data lake, but also have its own data language. And you can imagine, by having each data lake having a different data language, integration would become really difficult. The limitations at the time were both internal, regulatory, internal and external, but also technical. We did not have a central hosting capability that was able to onboard all users in a shared environment. But in the meantime, upgrades were being done all over the place, and our teams were working hard on this. So what was next for us, you might ask? Well, guys, we're now addressing this complexity by transitioning from the replicated model to a single data collaborative platform. And this platform is actually the key for us to implement the data fabric. All business units will reside in a single, scalable, and governed environment now. As you can see, making data available faster and through unified interfaces provided by the fabric has never seemed closer for us. Now, I would like you to do an exercise of imagination by looking at the screen. Over the last couple of slides, I have mainly talked about the benefits of the data fabric. But now, I would like you to imagine how the fabric it will look like for your organization or for your particular business case. Data fabrics stitch together data from multiple sources, repositories, silos, and create a network of information to power up your business processes. And this is the knowledge graph that you can see here. And another good thing about a data fabric is that it will not require you to rip and replace your previous investments. You can just reuse your existing data silos and expose data in the fabric. Metadata here plays a crucial role into creating the knowledge graphs. It lies on the foundation for any data fabric approach or architecture. Also, the usage of knowledge graphs will not try to force on you yet another format for your data. Instead, you can just reuse your existing formats to expose data to the fabric. Let's go in a bit deeper into the components that should be and can be found and should be found inside the data fabric. On the market, there are different perspectives regarding on which components should be included in the data fabric and how they should be composed. Therefore, a lot of vendor-specific implementations can be found out in the wild. But in the end, you don't even have to use components from a single vendor. You can just cherry-pick components from the open source world or from specific vendor, stitch them together, and you will create your fabric. Some typical components that can be found and needs to be found in a data fabric can include data ingestion. This component should be able to cater for any potential data format that you have lying around in your organization. It should also provide capabilities like streaming and batch ingestion. Then we have data management and intelligence. This component should secure your data and also apply the proper governance rules and policies to all of the repositories in which your data resides in. Data access. Users, technical, non-technical, business users, applications should be able to source data from the fabric using the interfaces provided by this component and the data fabric. And last but not least, data discovery. This one is one of the most important components that needs to be found inside the data fabric. For example, through this component, two users can search and consume data from two silos as if they were part of the same data set here. There are two more components on the screen, but I will not go into more details about them. And one last thing to add here is that the data fabric will take data discovery one step further by providing just-in-time access to all of the organization's data through unified interfaces. Let's see now how the data fabric translates into services and layers that we use and will use on a daily basis. From the bottom up, you can see that our new platform can connect to multiple data sources. internal, external APIs, databases, event buses, different data services, you name it, we almost for sure can connect to it. Furthermore, let's see how those services translate into logical layers. On the first layer, the collect layer, this is where our data from multiple systems sources will be consolidated. Here, we use data integration tools, extract, transform, load tools, but also data virtualization. The organized layer. In this layer, data becomes known, usable, and discoverable. Here, like I mentioned previously, we also enforce the governance rules and policies in accordance with our regulators and our internal rules. On the third layer, the analyzed layer, this is where our data becomes knowledge. Here, we have capabilities like reporting and dashboarding, from where our business users source their reports, but also AI and machine learning models will be trained using the data from the previous two layers. And in the last layer, the infused layer, based on the analysis previously done on the other layers, insights will be derived and business value is being gained here. We also use this layer to define new business processes, but also create new customer products. Now, I will give the floor to my colleague Oana to tell you more about how the fabric is implemented in ING, and of course, everybody's favorite part, the demo.
Thank you, Bogdan. Nice to see you all here. So before we move forward with the demos, let's recap a bit what are the four main pillars of a data fabric architecture. The first one, it must be able to collect all forms of metadata. And we talk here about business metadata, technical metadata, but also operational one. But just collecting and storing it will not be enough. We need to be able to understand and gain additional insights from it by defining statistics or key metrics on top of it. But we also need to define business relationships. So in the end, the business user can gain more information from using this additional virtual layer. By creating those relationships, we also enable knowledge graphs. So in the end, AI and machine learning algorithms will be able to use this semantic layer within their processes. And last but not least, it needs to have a robust integration backbone. So it needs to be able to cope with IT requirements, IT users, which are more complex, but also with business users that need to be able to integrate, self-integrate data, but also clean it for their additional processes. But how can we fit together all of this metadata that we are capturing and categorize it in different components? And for that, we are using an open source meta model, which is provided by Nigeria, that groups metadata into 8 main categories. The first one is related to base types, systems, and infrastructure. So different application infrastructure components that we use within the organization that store data, captured as data assets. In order to gain more information about these data assets, we can run metadata discovery processes on top of it in order to profile it, understand its data quality, but also to find additional information like classification on top of it. The semantic layer that we were talking about earlier is done using the glossary. This is the place where we store business concepts within the organization, and we will see at a later phase how we group all these business concepts together to create that knowledge graph. A big component will be data governance. We are a financial institution, so we need to comply with a lot of regulatory rules. And with the governance part, we ensure that our data management process follows all those regulations. The next component is collaboration. Within data management, we have different groups different roles that we are defining, like a data steward, a data owner, a data user. But we also capture feedback on those data assets that we have within our systems. And all of this metadata is classified as collaboration metadata. We have data that is generated by system, is transformed, and then is used by other systems. So we also capture that data flow or the lineage of those particular processes that are using the data. And last but not least, we have models and reference data. And we define different types of data models within the organization, but also have a place where we capture reference data to use it across. I was mentioning earlier that we have all these metadata elements, and how are they linked together? We chose just a small example to ensure that everyone can easily understand how easy you can adapt and enhance your metadata model. Everything is central around the business term. We are a financial institution, and we have a lot of business users, and they use business language. So it's important to create that knowledge graph based on the semantic understanding of each of the data assets. And these business terms are assigned to different assets, like database columns, database fields, but we also have other type of formats, as my colleague Bogdan mentioned, within the organization, and they can also be classified with the business concept. And all these data assets are stored in an application or different sources. You might already notice on the screen the color coded that we used earlier to classify each of these components. We need to ensure that we have the right quality for the data that at least we report to the regulatory, and maybe we need different quality scores for data that we just use for exploration purposes. So for that, we also have an area in which we define data quality requirements. We implement those data quality requirements, but we can further classify and group them in dimensions and apply specific criticality and thresholds depending on the need of that particular business concept. Data is consumed by different parties, and within our organization, we call that a business initiative. It's nothing more than a consumer. And in order to consume that data, you need to have an exchange agreement in place in which additional metadata is captured in terms of retention and what is the particular scope for consuming that data. And in order to classify that scope, we introduce an additional component, additional concept, which is called metal, that actually classifies the risk of a specific business initiative. For a regulatory reporting, it needs to have more things in place than just for internal use. But in order to create that knowledge graph, we also need to create relationships between business terms. And we store all the business terms into a glossary that we call Esperanto glossary. Esperanto is the one language for the bank, as we call it. Maybe you are familiar with the actual one language that is defined called Esperanto. And we have data grouped in different categories. And we're going to navigate a bit through the party data. We are a bank, so the customer is our main focus. But we also want to keep our customers happy by providing good products and services. But at the same time, we need to ensure that the customers that are onboarded on our platforms comply with all the regulatory rules in place. But we also allow, besides the global glossary, for different domains to have their local ones. So it might be familiar that in Romania, we refer to it as a client rather than a customer, so we can create a relationship of type synonyms between them. And a customer can have specific properties that will be defined with an additional relationship, which is has a. So a customer can have a date of birth, it can have a first name, and it can also have a last name. We already have here different connections that we can create between business terms. And a customer can be represented either by a natural person or an individual or by a company or a legal entity that's represented as an organization. And if we further want to group this information together, we can define additional relationship like is a type of party. And this way you can see how we can group all the business concepts within the organization to make sure that they have a relationship together. And later on in the demo, we will see how that knowledge graph is represented. Just another example of how additional party around product can also group the specific business concepts together. But now let's move on towards the demo part. We're going to showcase a few of the activities that a data steward will do. And in terms of skill, a data steward has the profound domain knowledge in the area that he is working with, and he is also the quality gate for different type of data that we store. It's also a person that's easy to adapt to different situations and has the ownership mentality. And in terms of skills, it takes care of data ownership, data governance, and to refine and gain insights in data. We will be presenting 5 activities. We also mentioned earlier about the key pillar, but also my colleague Bogdan mentioned different components that the data fabric architecture needs to have in place. And you will also see how we mix different vendors in order to create this view. We will start with data virtualization. So data virtualization will actually show how the information can be taken from different silos and treated as one data set. So I am now logged in on our data platform, and I can easily navigate to the data virtualization screen. And here we see a constellation view of different sources that are grouped together, from which I can choose what information I want to group together and create a new virtual data set. So we are going to navigate to two sources that contain information about Know Your Customer for our financial crime risk management, but also to another connection where we store reference data. In this case, we want to additionally classify our transaction with the industry classification for those payments that were done with the credit card. We see here the list of tables that we want to virtualize, and a data steward can create new data sets. He can do directly from the UI. He can join two tables. I know this is quite a simple example, but if we need to apply additional complex transformation or to join multiple tables, we can also easily do it from the SQL editor if the data steward knows well the syntax. So here I've already created the join, and I selected the columns that I want to have in my data set, and I can easily rename them to make them easier to understand. In this screen, I define what will be the new name of my data set, so I will just call it Transaction Enhanced, as I added additional information to our data set. And if I want to create additional and to add additional visualization to it, I can assign it to a project. A project is a bucket in which we can add additional type of assets and enrich the data that we have sourced from different tables. The next part will be metadata enrichment. So what do we do during the metadata enrichment task is we have a machine learning algorithm that helps us classify, assign business term, and also assign data classes. So understand the data quality score of those particular data sets that we want to scan. So for that, I'm going back to my project, and I'm going to enrich the transaction table to see what are the potential business terms that can be assigned to it, what is its quality, and what is the profile. We can easily do that by selecting the data asset. And of course, if you have more table, you can select them from there, or there is another functionality that imports several assets at the same time. So here we see the options with profile, analyze, and assign terms. And we can choose what are the glossaries that we want to use for this assignment. In this case, we chose the global one. And also choose what is the sample for our analysis. Once we are ready, we can create this new asset that will go and profile the information that we have. So we see that it already suggested a few assignments. The confidence score is set to 80%, so anything less, it will just suggest, and the data steward will need to manually assign it. We can change this confidence level, and also next time when we run it, the model will know that the assignment was done, and it will automatically assign it for you. We don't need to do it again. We can do this on column level, but also on table level. So in this case, I'm just going to manually assign one since I didn't have any suggestions. And once we are ready with the assignments, we can review these assets. And by reviewing, we just click the table and then on the columns as well, and we mark them as reviewed. Assets that are reviewed can then be further published to a catalog where we have all our assets within the organization available with their semantic layer associated, but also data classes and quality scores, and where they are profiled so other users, data users, can see and search for them. The next part is data refinery. With a data refinery job, you can actually clean the data based on specific needs. By cleaning this data, we generate a new data asset. And a data steward can easily do that from the platform without the need for a data engineer to go and do that for them and to replicate that information. So we see here the profile that was generated earlier, and then we notice that for date of birth, we don't have a timestamp, but we actually have a string. So what we can do, we can easily change that data type by cleaning the data. But if we click on the steps, we can also see that we have additional actions that we can take by either removing specific values, adding a default one, filter the rows, or split it into different words. So in this case, we navigate to the column. We select the new data type that we want to have. We select the format of the information, and then we just generate it. Once we are ready with all the changes that we want to do, we can create a job. This job will have a name and can be further configured to do specific actions. In this case, the environment that we want to run against and the retention. But also if we want to schedule it to run it at a specific times or just when it's manually triggered. So we're talking earlier about all the connections that we do with the different metadata elements. And we're going to show how we create reports based on that metadata. And for that, we use a different tool. And you see here that we have different reports that were built. I'm going to select one of our domains. And for a particular date, we see the screen split in 3. We have scores, sources, and consumer. All this information is based on the metadata that we are capturing in our data catalog. And we see what are the data governance scores within the data lake, and also split based on different applications, but split also on different business consumers. We can further drill through to understand what is the situation and how we ended up with that particular score. And here, this information is grouped in 3 main categories that we want to monitor on our metadata. And even further, to understand how the governance percentage was calculated, we go to the actual atomic level where we see the columns, we see the sources, the tables, the columns, and the particular components that created that score. So in this case, the last one were the ones with 100%. The next part is about the semantic layer. So we had all those business terms that were created, and they have different relationships. And for that, we create a graph that represents all those relationships that we can navigate to. So let's filter on something to make it a bit simpler and better to understand. So I'm going to filter on the date of birth business term. In the result, we see that it's linked to 4 other terms, and it has 2 types of relationship. Is a type of, and it's also is of. So is a property of 3 other concepts. If we want to additionally enhance this view, we can add additional terms and see how they relate to each other. So in this case, we see that the country of birth is linked to the similar concepts of date of birth, and they also have additional components like business initiative, data quality rules, or the actual data assets that they are linked to. So as you could see, data fabric architecture actually speeds the time where you get insights. You can play with the data where it resides without the need to replicate it. You can also work with better data because you can easily clean it. And in the end, it will greatly help our business user easily gain access to the information that they need in order to create new products and services.